In this video today, 5.6, we're going to be talking about writing an equation of a line, continuing with that. But this time it's going to pass through a point and is parallel or perpendicular to a line. We learned in the last videos that to write an equation, we need to have it in the form of y minus y1 equals m times x minus x1, where we have a point and we have a slope. So if it passes through a point, that means we have the point. And if it's parallel, what do we know about the slopes of parallel lines? We know that m1 equals m2. The slope of perpendicular lines, we know that m1 equals the negative 1 over m2, the negative reciprocal. So we can find, if we can find the slope of the parallel line or the perpendicular line, we'll already have half of the part we need to write an equation. So here's an example. We want to write an equation of a line that passes through 1.4 and is parallel to 3x plus 2, 5 equals y. What do we know about parallel lines? m1 equals m2. So if we know the slope of this line, then we'll know the slope that we need over here. Because to write an equation, we need to have a point, this is x1, y1, and a slope. So I don't know the slope yet. I'm going to find the slope by finding the slope over here. So how do we find the slope of an equation, of a line? We solve for y. So I'm going to subtract 3x from both sides. 2y equals negative 3x plus 5. Divide by 2. Y equals negative 3 halves x plus 5 halves. Remember, in a line, when we solve for y and we have y equals mx plus b, this here is our m and this is our y-intercept. All we care about right now is the m. So we know that m1 equals negative 3 halves because the slope of this line over here is negative 3 halves. So now I know that this is negative 3 halves. So now that we have a point and we have a slope, we can write the equation. Y minus 4 equals negative 3 halves times x minus 1. This is my y part, this is my x part, and now we can solve it. Now on Connect Math, they may ask you to write it in standard form or they may write it into slope-intercept form. So you just have to be careful on any question and read what form they want them in. So let's solve this. We're going to put ours into slope-intercept form. So I'm going to have y minus 4 equals negative 3 halves x plus 3 halves. I'm going to add 4 to both sides. Y equals negative 3 halves x. This would be 4 over 1, so I need to multiply it times 2 over 2 to get 8 over 2. So this would be 3 plus 8, which is plus 11 halves. And there is my slope, an equation of a line that goes through 1, 4 and is parallel, and you can see that they both have the same slopes. Okay, there's our line. Now let's do one where we're perpendicular. Okay, we want to go through negative 2, 3, and perpendicular to 3x plus 2y equals 5. Okay? So we want to write an equation of a line that goes through negative 2, 3, and it's perpendicular to 3x plus 2y equals 5. So if you see this on a test, you're like, oh my God, I have no idea what's going on. You just start writing down what you do know. I know that perpendicular means that m1 equals the negative reciprocal of the second slope. So if I can find the slope of this one, I'll know what this slope is, right? So let's find this slope. I'm going to solve for y, and then I'm going to divide by 2. Y equals negative 3 halves x plus 5 halves. My slope of line 2 is negative 3 halves. Now remember, this is going to be the negative reciprocals. So m1 is going to be, this is negative, so this one's going to be positive. This is 3 halves, so it's going to be 2/3. So they are negative reciprocals of each other. So now I have a point and I have a slope, so now I can write my equation. Y minus 3 equals 2/3 times x minus negative 2 Simplify. Y minus 3 equals 2/3 x. This becomes a plus 4/3. I add my 3 to both sides. Y equals 2/3 x plus, this would be times 3/3, would be 9/3. So 4 plus 9 is 13/3. Here's my equation of a line in slope-intercept form. This is slope-intercept form. Y equals mx plus b. Standard form is the ax plus by equals c. Okay? All right. Let's see. Let's do one more, and then we'll call this section done. We want to go through 1, 3, and it's perpendicular to x equals 2. Okay? We want to write an equation of the line where it goes through 1, 3, and it's perpendicular to x equals 2. Now, when you have a line that is like x equals just one number, or y equals a number, so like x equals 2, y equals 4, y equals 1/2, it's best to sketch or graph this one first. Let's graph x equals 2, and let's see what that looks like. Remember when we have x equals 2 or x equals any number, just that number, no y's whatsoever, all our x points are going to be 2. Every x point you could ever decide is going to be 2. So here's my x points, 1, 2. So this one is going to go just like that, right? That right there is this line. X equals 2. I just graphed it. Now we got to remember that it's got to go through this point, 1, 3. So here's 1, 1, 2, 3. About right there is 1, 3, right? Would you agree? Okay. We want it to be perpendicular. What does that mean? That means that they made it right angles. They make like the T. That's how come we use perpendicular, where it looks like a T. So I'm going to draw this line that we're wanting. It's going to go kind of like that, isn't it? Because that meets at right angles. So that's the line right there that we want to write the equation of. What is this line? If I started naming off all these points, this one would be 1, 3. This one down here might be -2, 3. This one over here might be 4, 3. What do we notice about all of these? All of these have y equals 3. So that right there is going to be our equation of this line. So once again, if you have something that just says y equals 3, x equals 2, anything like that, graph it first, and then graph whether you're wanting it parallel or perpendicular, and through that point, and then write your equation. Okay? Have fun, and I'll see you at the next video.